Departing from Tethys, we move out to Dione. At first look, it may appear as a less interesting version of Tethys, a moon it shares many surface similarities with. But don't be fooled, there is more here than meets the eye. Here's an interesting fact about Dione. It's the 15th largest moon in our entire solar system. But if you were to take up all the moons that are smaller than it and add them together, they still wouldn't have as much mass as Dione has. One of the first noticeable things that sets Dione apart is that it seems to be facing in the opposite direction. The clue is in how it's cratered. For most tidally locked bodies, the front or leading side receives the majority of the impacts as it hits them head-on while traveling through space. On Dione, though, this appears to be reversed. It wears most of its craters on its trailing side. So what happened? Well, there is a theory that perhaps Dione suffered a collision. Maybe one of the impacts that created one of these larger craters hit with enough force to turn the moon. That said, the fact it seems to have spun the moon almost exactly 180 degrees is something scientists find more than a bit unusual. Dione may look like a bland cue ball in space. Slowly but surely, though, it continues to reveal its mysteries. Perhaps of most interest to astropointers, though, is the fact that Dione has an orbital resonance with its neighbors, Mimas and Enceladus. On top of that, there are indicators that this moon may also have or had an interior ocean. Think of Dione as a weaker or defunct version of Enceladus. This tidal heating has created some of Dione's most interesting features. When Voyager flew by in 1980, it photographed what became known as wispy terrain, a mysterious set of highly reflective lines on its trailing side. When Cassini arrived decades later and rephotographed the wispy terrain, it revealed that these features were actually massive cliffs, some several hundred meters high, fractures in the land, their reflectivity brought about by the exposed ice. While the cliffs will be fun to explore, they're not the place we're most interested in. Tidal heating, the forces that are suspected to have created the cliffs, are also responsible for the top candidate of Dione's high point. Even more so, the events surrounding that location are one of the biggest clues that Dione may have a subsurface ocean. The Janiculum dorsa is a massive ridge running in length about 500 miles and ranging from half a mile to about a mile and a quarter in height. From in-depth review of the Cassini images taken of this moon, it appears that this mountainous ridge came about from compression of the surface. For scientists, though, it was what was running next to the ridge that was of most interest. On both sides, there were depressions created by the weight of the ridge itself. And this is known as isostasy, or gravitational equilibrium. We say that the crust floats on the mantle. In a very, very simplified fashion, you can understand this as the more weight you put on the crust means it depresses it. The less weight means it rises. We see a similar thing here on Earth with mountains pressing down on the surface of the planet. We get this due to having an active mantle. But what would create such an effect on distant, frozen Dione? The answer is thought to be a subsurface ocean. Combine this with the tidal heating, and you would start to see a similar effect on Dione that you see here on Earth. So the thought is, Dione either still has liquid in its interior, or at least it did when the ridge was formed. Further study will be needed before we have a definitive answer. We're going to be focused on the ridge, particularly getting to the top of it. At about 5,500 feet, this should be a relatively straightforward affair. Once on top of the Janiculum dorsa, you'll be able to take in this massive ridge and the depressions running alongside of it. All of them indicators that Dione may just well be a lot more intriguing than it lets on. We're now moving into the larger outer moons, though our first stop is very reminiscent of the last two that we just visited, with one exception. It's about a third bigger than Tethys and Dione. Rhea is the second largest moon orbiting around Saturn, and the ninth largest moon in our solar system, with a diameter of 949 miles. This was another of the moons discovered by Giovanni Cassini. Rhea is the smallest moon yet discovered in our solar system that appears to have been rounded by hydrostatic equilibrium. From a distance, it looks basically like an upscaled version of Dione, and it shares many of the same characteristics. But a closer look reveals a moon that, from all appearances, looks like it went the distance, the heavyweight champ. Rhea is an ancient world. In some ways, it's very similar to its Jovian counterpart, Callisto, another world who is cratered extensively. Rhea's cratered plains date back almost 4 billion years, though the craters here are a bit different than you'd find elsewhere. They don't have the defined crater edges of, say, Mercury or our moon. Like Callisto, the craters on Rhea are in a much more relaxed state. Rhea is not only the most heavily cratered moon orbiting Saturn, but also one of the most heavily cratered objects in our entire solar system. In some parts of this moon, you can't find smooth terrain because it has been impacted so heavily. The two largest craters that you can find here are Mamaldi and Tirawa. These two craters actually overlap together. Tirawa, the younger and smaller, overlapping the larger, older Mamaldi. Tirawa was 220 miles in diameter, reaching a depth of up to 3 miles below the surface level. For astropointers, one of the more interesting things is the elongated central peak found in the crater's heart, brought about by the angle of the original impact. The crater Mamaldi lies southwest, and it is 300 miles in diameter, but much more degraded in its appearance. There's more to Rhea than just its battered appearance, though. It actually has an atmosphere, an oxygen one on top of that, which is pretty remarkable, because outside of Earth, that's the only one we've discovered so far. Now, don't expect the breathing to be easy, because Rhea's atmosphere is more of an exosphere, and it's 1,000 times less dense than the one on our home planet. Rhea may also have a ring system, which would be pretty remarkable. The Cassini probe found evidence that such a feature may tenuously exist, or, if it all existed at one point. The clues were deposits located around the equator, though there is still some fierce debate if this was actually the case. If so, Rhea would be one of the first moons ever found with such a feature. Of the Saturn VII, Rhea's the moon where we're going to have to put in the most legwork when it comes to determining the actual high point. There isn't even much in the way of clues, and this moon's relaxed ancient surface doesn't really do us any favors. Now, Cassini has provided some images that have been topographically enhanced, but we actually don't have a full moon version of that. And even more so, the data from Cassini is still being worked. So perhaps in the future, we'll have a better understanding of the topographical nature of this moon. Here's what we do know. Rhea is made up about 75% water ice, with the rest being rock. As with its counterparts, this composition means that any high point on Rhea is probably not going to be all that high in the big scheme of things, adding in the fact that one of the peculiar things about this moon that works against us is, despite residing in a relatively crowded neighborhood, it does not appear to have orbital resonance with any of its neighbors. That means any energy needed for geological activity has to come from external sources. We actually have a pretty good view of Rhea, but our picture is still incomplete. Cassini passed by this moon on multiple occasions, and it imaged it every single time. Except it never got it in its entirety, particularly around the polar regions. The imagery we have for those areas comes from the Voyager missions in the late 1970s. And while state of the art at the time, that technology can't provide the clarity or detail of the equipment that was on board Cassini. Rhea can basically be divided into two regions. One is the heavily cratered bright terrain, with craters larger than 25 miles in diameter, and then the polar and equatorial regions, where craters are much smaller. The difference in these areas most likely indicates that Rhea has at one point had some major event happen that led to resurfacing parts of the moon. So yes, finding a high point on Rhea is going to be a bit of a challenge, because it just has not been determined yet. You may wish to consider this as a bit of foreshadowing, as our high-pointing adventure moves further out in our solar system. Based on what is known, your best opportunities for success could be going to the poles of the moon. Topographical mapping has revealed highlands in both the north and south poles of Rhea. This moon also has, at least to a lesser extent, the wispy terrain found on its neighbor Dione, so that too could be a potential area to explore. There is also that faint ridge at the equator to check out, the potential clue for Rhea's ring theory. It's not a lot to go on, but it is something. So, where does that leave us, though? From an astropointing perspective, not in the best of circumstances. From a scientific perspective, the lack of a clear, distinct high point tells us some rather important things. One of the reasons that mountains and high points are of interest to scientists is they can provide a good bit of information about the worlds on which they're found. Geological activity requires energy, whether it's internal or external. Earth's mountain chains are the result of plate tectonics, which in turn tells scientists that our planet has an active core. The massive Martian volcanoes show us that at one point Mars too was active, but their height means that the hot spots didn't move. The absence of such things can be just as informative. Rhea's surface and the age of its structures and formations are all part of a bigger puzzle on understanding this particular moon. Someday, we shall know for certain what Rhea's high point is, whether through further analysis of Cassini findings or when we send our next probe to Saturn. All these factors could still add up to something interesting for astropointers, particularly the completionists. Rhea could well be home to the lowest high point in the Chronian system. And while we may have struck out on this moon, overall it's not going to have too much effect on our solar system high-pointing adventure. Unfortunately for us, the last 2 moons orbiting around Saturn that we're going to visit are more than going to make up for any disappointment we had here. Of the 7 moons we have opted to explore around Saturn, one of them stands head and shoulders above them all. The orange monster of Titan. Make no doubt about it, of all the moons in our solar system, Titan is one of the most special and can truly be called unique. Titan is the unchallenged lord of Saturn's moons, dwarfing all the others. To put this in perspective, about 96% of all the material orbiting Saturn is contained in Titan. Almost all the other material in the remaining 4% is held by its 6 regular moon counterparts. The remaining moons, rings, and moonlets only take up a minuscule 0.04% of the material. A better way to think about this is imagine you had $10,000. 9,600 of those dollars would go to Titan. $399.96 would go to the other 6 major moons. And finally, that last 4 cents would go to everything else orbiting around Saturn. Titan isn't just the big kid of its neighborhood, but also the 2nd largest moon in our solar system. Only Ganymede is larger, and Titan, like its Jovian counterpart, is also larger than the planet Mercury. It shouldn't be any surprise that Titan was the first moon discovered revolving around Saturn. Christian Huygens first observed it in 1655. It was the first moon discovered after Jupiter's Galilean moons. Since it too was orbiting around another planet, it served as validation that Galileo's theories were correct. One of the big mysteries of Saturn's system of moons is why there is such a substantial drop-off from its largest moon, Titan, to its 2nd largest moon, Rhea. Why doesn't Saturn have a system of moons more akin to, say, Jupiter and its 4 large Galilean moons? Well, that's a conundrum that is still being unraveled. The going theory is Titan managed to form in a bit of a safety zone, far enough away from the gas giant to take shape, but also to avoid becoming lunch by Saturn. It may have had counterparts of similar size at one point, but they may have formed too close and were gobbled up by the ringed gas giant. For a long time, Titan was thought to be the largest moon in our solar system. That assumption was due to one of the features that makes Titan truly unique among all the moons in our cosmic backyard. It's the only moon discovered so far that has a substantial atmosphere. It stretches up from the surface over 350 miles. This atmosphere is so thick it actually threw off estimations on the size of the moon. The element nitrogen makes up most of Titan's atmosphere, about 95% of it, with methane making up most of the remaining 5%, along with a tiny bit of hydrogen and other hydrocarbons. This dense atmosphere also has a higher pressure, about 1.5 times higher than that here on Earth. Combined with the moon's low temperature, that means Titan is very close to the triple point for methane, where liquid, solid, and gas phases of it can all coexist. The distinct color of Titan's atmosphere comes from what's known as tholins. Tholins are bits of organic hydrocarbon compounds that are created from the reaction of Titan's atmosphere with the sun's solar radiation. These compounds then work their way down to the surface. The opacity of its atmosphere meant Titan would remain a mystery for a long time. Like the planet Venus, Titan's cloud cover kept its secrets well hid. Even when visited by Pioneer and the Voyagers, Titan remained an enigma. None of those craft were equipped to peer beneath its clouds. It would take a remarkable bit of engineering to find out more information about this moon. When Cassini was launched, it actually had a passenger, the Huygens lander. And this small space probe, weighing about 850 pounds, had the goal of traveling through Titan's atmosphere, landing successfully on the surface, and then transmitting data back to Earth. On January 14th, 2005, the Huygens lander touched down on Titan, becoming the furthest space probe humanity has ever successfully set down on another world. Its 2-hour and 27-minute descent through the thick clouds peeled back some of the mystery of Titan and finally gave scientists their first look at the surface of this long-hidden moon. The findings would be astonishing. Titan was already noteworthy for having its dense atmosphere, but it would become even more exceptional upon the discovery of standing liquid on its surface, a trait that is only found in one other location in our solar system, here on Earth. Of all the moons in our solar system, Titan is the most planet-like. If humanity ever wants to make a go at colonizing the outer reaches of our solar system, then Titan may well be our best chance for success. In a lot of ways, it's like a bizarre version of Earth, a surreal but familiar landscape with mountains, rivers, lakes, deserts, and plains. The difference, of course, is what makes those features up. On Titan, water takes the shape of rocks, and that standing liquid, it's actually methane. Because Titan can charitably be described as a bit cold, as in 290 degrees below 0 Fahrenheit cold. But despite this frigid temperature, this moon has all the components necessary for life. Except it'd be a type of life that evolved along a very different path. Highpointing under the orange skies of Titan is going to be a bit different than many of the other locations we've been to. For starters, you can ditch the spacesuit. There's enough atmospheric pressure here where you won't need it. All you'll really need is an oxygen mask and some really, really good cold weather gear. There are several other advantages you'll have as well. Gravity on Titan is comparable to our moons. If you weigh 200 pounds on Earth, you'll come in around 29 pounds on Titan. Another benefit of climbing here is you'll get a break from the radiation. The dense atmosphere helps mitigate that as well, providing a level of protection we haven't had since Earth. Before we venture to the high point, though, we're going to want to check out a few of those sites that Titan has to offer that are unique in our solar system. And I think for most people that means those methane seas, lakes, and rivers. Because if people ever can visit Titan, then Titan's beaches are surely going to be the place to be.
Titan's seas and lakes are mainly located near the North Pole. The largest of these is Kraken Mare, a body of liquid that, at 154,000 square miles, is larger than the Caspian Sea here on Earth. It has a depth of at least 500 feet, but potentially it's even deeper. NASA is already working on a concept to send a submarine probe to explore these seas in the next few decades.
Another site you're going to want to check out are Titan's dunes. These features are impressive. They can rise up about 300 feet with a width of half a mile, and then they stretch for hundreds of miles. But they're not made of, say, a silicon-based sand. Remember those tholins? Those hydrocarbon chains fall back onto Titan's surface where they accumulate. Then Titan's wind comes along and it blows them into the shape that we find.
At least, that's one theory. Titan's dunes are, like seemingly everything else on this moon, weird. They face the wrong direction for starters, facing the opposite direction of the prevailing winds. And they may well be able to do that because the particles that make them up may have an electric charge, causing them to statically cling to each other like laundry fresh out of a dryer.
There is also a thought that maybe the dune's creation is more complex than we realize, with elements not only coming from the air, but being manufactured on the ground as well. Whatever the case, if you visit Titan, you're most assuredly going to want to check this place out. While it's easy to get caught up in the weird, wild, wonderful world of Titan, we're here for Highpoint. And while the last few Saturn moons have been a bit of educated guesswork, scientists actually have identified the orange monster's highest bit of elevation.
Titan actually has several distinct mountain ranges, but how they are formed is still open to debate. This moon appears to have a very large mantle made up of water, and there are several ideas of what forces are at work affecting it. One being tectonic activity from the moon's core, another tidal friction from Saturn, or compression as Titan slowly cools. Or maybe it's a combination of all these. A majority of the ranges discovered can be found around the equator of the moon.
If you're a fan of J.R.R. Tolkien's seminal work, The Lord of the Rings, well, then this is the moon for you. All the mountain ranges on this world are named after places in Middle-earth. You can even live out your ring-bearer fantasies with a visit to Mount Doom.
Doom Mons is not the fiery spire it is in the book, though. Almost completely opposite. It's still a volcano, but in true Titan Bizarro World fashion, it's a cryovolcano. Instead of erupting molten hot magma, this one erupts water from Titan's watery interior.
Even without the Tolkien tie-in, astropointers would want to visit this peak. Located deep in the southern hemisphere, it's thought to be one of the largest cryovolcanoes in our solar system.
The Doom Montes are one of the largest mountain ranges on Titan by volume, and the peak itself comes in with an elevation of 4,757 feet. If you opt to climb it, it won't be a pleasant one. In true Titan fashion, it'll be a bizarre version of Frodo's trek. Doom Mons appears to be an active volcano, and to add to it, The slopes of the mountain are pelted with methane and ethane wind, rain, and snow, whipping up hydrocarbon dust, resulting in a stew of smog and haze.
After fulfilling your fantasy to save Middle-earth, it'll be time to head to the high point. You can find it near the equator, in a group of ridges called the Mithramontes. And while you take them in, you might think they look rather pedestrian compared to some of the peaks we've climbed so far on our journey. But there's a very good reason for that. And it all has to do with what Titan's mountains are actually built up from.
Titan's peaks will never reach the height of peaks we would find here on Earth, because instead of being made of rock, they are made up of water ice. And while that ice may feel as hard as rock, it is still subject to the laws of physics. The density of water ice is significantly less than stone, meaning it just can't hold together as you pile more and more material on it. So for Titan, that means that its tallest peaks cap out around 10,000 feet.
The Mithramontes are a group of 3 ridges that are each about 15 miles apart from the other. They run east to west, and the one we're most interested in is the one furthest to the south. Now, there are a couple challenges we're going to face when it comes to highpointing on Titan, and one of them is a chance of precipitation, though the nature of rain on this world is still up for debate.
There are some theories that argue that the rain is constantly falling in some fashion. Another line of thinking is that rainfall here is much more infrequent, sometimes taking centuries to happen, but when it does, watch out. It comes down in a deluge, falling not in inches, but yards at a time. Keep in mind that Titan does have seasons, so that could affect the weather as well. Now, a word about those seasons is they are 7.5 years long, so you'll want to make sure you're planning your arrival for the right time of the Chronian year.
Another potential issue could be that static electricity mentioned earlier. You could well find yourself trudging up the mountain covered in a hydrocarbon gunk. But perhaps you don't need to hike up this mountain in the first place. Titan affords a truly unique way to summit its high point. It's perhaps the coolest in our entire solar system. You can literally fly. I'm not talking about taking some aircraft. Because of its low gravity and the high atmospheric pressure and the density of the air itself, you can quite literally strap on a pair of wings and do a modern-day Daedalus and flap your way to the top.
Once you land on the summit, you'll be at an elevation of 10,948 feet, the highest point on Titan. The view from here will be a fascinating sight, perhaps most like Venus, but without the crushing atmosphere and replacing the infernal heat with bitter cold. Be able to take in the Mithramontes to the north and the foothills to the south. It will be one of the most surreal views in the solar system. So familiar, but still very alien.
As we finish our adventure on Titan, it'll be time for us to move to the outer reaches of the Chronian system. But don't worry, Titan won't be unvisited for very long. NASA plans to return with the Dragonfly mission in 2034.
Saturn's moons have piled up a whole stack of mysteries and wonders that have yet to be solved, and our final destination, the distant moon of Iapetus, is no exception. In fact, not only could it easily compete for the title of Saturn's most mysterious moon, it's also a contender for the weirdest moon in our solar system.
Iapetus is the third largest moon orbiting around Saturn, with a diameter of 912 miles. It's the 11th largest moon in our solar system, just missing out on the top 10 by a measly 34 miles. Discovered by Giovanni Cassini in 1671, it was the second moon found orbiting the planet, and it has been puzzling astronomers from the get-go.
Iapetus is a moon of mysteries, but there are three in particular that really set it apart from its fellow moons. The first of these is its disappearing act, a mystery that revealed itself shortly after its discovery. As you approach this distant moon, the first thing you'll notice is its coloration. Depending on your angle of approach, it may appear as the ancient Chinese philosophical symbol of yin and yang. This distinct difference in color would be the key to understanding Iapetus's first big mystery.
When Cassini first observed this moon, he noted that it kept disappearing through its orbit around the planet. His hypothesis was that perhaps it had two distinct colors, and that he'd be able to see it if he had better telescope technology. Fast forward several decades, and sure enough, Cassini, with a better telescope, was finally able to track the moon through its entire orbit. And sure enough, the one side was significantly darker than the other.
What was giving Iapetus this contrast in color was still a mystery, though, and it wouldn't be solved until much more recently, when the space probe named after the great astronomer would discover the clues to finally solve it. Iapetus has the greatest variation in brightness of any object known in our solar system. An easy comparison would be comparing, say, asphalt and fresh snow. How this came to be, though, is dependent on yet another of Saturn's far-orbiting moons, one briefly spoken about in the previous episode, Phoebe, the ring giant's largest irregular moon. It produces a ring of dust, thought to be material that has been knocked off the moon by collisions. This material formed a ring around Saturn, and Iapetus ends up plowing right through it. Think of it like driving a car and all the bugs hitting your windshield. That material darkened the surface of Iapetus and started a chain reaction that would lead to its current coloration.
Compared to its Chronian siblings, Iapetus is the member of the family who lives away from everybody. Not the next city or even next state over, more like on the other side of the world away. And that is this second big mystery of this moon. How did it get where it is?
It's surprisingly far away, orbiting Saturn at an average distance of 2.2 million miles. It's the largest moon discovered orbiting at that great of a distance from its planet. In addition to that, it also has an unusually high orbital inclination, compared to its peers. Of the major regular moons, most sit fairly level with Saturn's equator, a majority of them with less than a degree of inclination.
And then there is Iapetus, with its whopping 15.5 degrees of inclination. Now that may suggest that perhaps Iapetus isn't from around these parts, that it was just passing through, liked the neighborhood, and decided to move in.
That doesn't seem to be the case, though. Compositionally, Iapetus appears to be made up of the same material as its Chronian counterparts, mainly water ice and some rock. Also, the eccentricity of its orbit, or the amount its orbit deviates from a perfect circle, is rather low. lower than it should be if it had been a captured object.
So, what happened? Well, that's still a bit of an unsolved mystery. But one of the going theories is that in the early days of the solar system, Saturn had an encounter with another planet, perhaps one of the ice giants. And in that event, Iapetus was pulled into its current orbit.
Its distance and high angle from Saturn make Iapetus rather difficult to visit. The Cassini orbiter was only able to make one up-close approach to the Moon during its entire mission. That visit would raise more questions than answers, and only deepen the mysteries of this moon. But for astropointers, it would reap huge dividends. While the two-toned appearance of Iapetus is one of its most noticeable traits, a closer, more detailed look starts to reveal other quirks and idiosyncrasies. Iapetus is not quite round. In fact, it is the largest discovered body in our solar system that has not achieved hydrostatic equilibrium. That alone would make it interesting to any astropointer completionist. But in addition to that, it is also flatter than it should be. It's over 43 miles shorter from pole to pole than it is wide across the equator. And that's a difference of about 4.5%.
For a point of comparison, Earth's rotational flattening is 0.3%. Now, Iapetus' rotational flattening would make sense if it had a day of about 16 hours, not the over 2.5 months it does have. This is arguably another indicator that Iapetus didn't start where it finished up.
As you continue to gaze at it, you may also notice it has quite a few large impact sites. More than a moon this size probably should have. Iapetus has at least 5 of them, measuring over 200 miles in diameter. The largest of these is named Turgis, with a diameter of 360 miles. It's notable for its extremely steep rim that has an estimated height of 9 miles. And that distinct sheer drop is rather weird for this moon as well. Finally, you'll notice Iapetus seems to be wearing a belt of sorts running around its waist, giving it a walnut-shaped appearance. It's this feature that we're most interested in. Iapetus has a mountain range, one that is unlike anything we have seen before in our solar system. It's so tall that it visibly distorts the moon, and this range is the third big mystery of Iapetus. The first clue that something special may be here came when Voyager flew by in 1980. It provided a tantalizing glimpse of what was thought to be several mountain peaks that were aligned. It was a small curiosity that puzzled scientists, who named them the Voyager Mountains after the space probe.
It was Cassini's visit to Iapetus that would throw back the curtain and reveal that this small curiosity was something much grander and stranger than scientists imagined. It's now known as the Equatorial Ridge, and it's here where we'll find the highest point in the Chronian system.
For starters, the Equatorial Ridge is substantial. It runs for a distance of over 800 miles and stretches more than halfway around the moon. There are suggestions that at one time it may have been even longer. It has a width varying from 12 miles to 120 miles in places. Even more amazing is that if you run the numbers, this range seems to take up 0.1% of Iapetus' total mass.
Now that may seem like a small number, But on a global scale, that is a lot of material going in to build a dominant feature on this moon. And these mountains, they are tall, like really tall, up to 12 miles in height. Even the isolated peaks on this range are up to heights of 6 miles. And that is taller than Mount Everest here on Earth.
It's here where things take a turn for the weird, though, because this range pretty much runs straight as an arrow around the center of the moon. There's also the fact that, despite the amount of mass it has, it doesn't seem to depress the surface of Iapetus like other comparable mountain chains would. Even more peculiar is outside of the impact craters, this seems to be Iapetus's only dominant geological feature.
So the big mystery is, how did this range ever come to be? Because, make no mistake about it, this range is an oddity. It doesn't seem to follow the rules, and it raises more questions than it answers. It is one of the unique structures in our solar system, because we have found nothing like it anywhere else.
There are multiple hypotheses on the creation of this range. One is that it came about from the collapse of a ring system around the moon. Another is that Iapetus was able to capture a moon of its own, but it got too close and was destroyed, the debris raining down. Another idea is that in its early days, Iapetus had an exceptionally high rotation rate that flattened it and created the ridge. It's also been proposed that maybe Iapetus cooled very rapidly, and the crust buckled and uplifted.
The thing is, none of these hypotheses are conclusive. They all have their flaws and detractors. The only way we have a shot of figuring out how this range came to be is to actually go back to Iapetus and explore it further. There's also another question that demands an answer. How did these mountains get so unusually tall? Because based on everything we've seen so far, they really shouldn't be.
Iapetus is thought to be of a similar composition as Rhea, Dione, and Tethys, another world that is mainly water ice and a bit of rock. If that's the case, though, then why are its mountains so high? Because everything we've seen so far says they shouldn't be.
On Dione, one of the ways they were able to identify the Janiculum dorsa was by the depressions running along the sides of it. So you would think, because of the magnitude of the equatorial ridge, it too would have such a feature. But here's where things take a turn for the weird. There is no sign of such a thing in any way, shape, or form. And that, frankly, is astonishing.
This has led scientists to believe that the ridge wasn't created until after Iapetus had vented all its heat after its formation, when it was a truly dead world. But while the range is newer, it still is ancient enough to have been pockmarked by crater impacts over the eons.
The thought is that Iapetus is completely frozen through, and that's due to its distance from Saturn and its high orbital inclination. Because of those two factors, the planet and its moons never get a chance to really tug at Iapetus and create that tidal friction. And this also means that Iapetus seems to have escaped any major resurfacing events.
There is so much we don't know about this ridge, including the definitive heights of many of the individual peaks. There appears to be numerous mountains of significant elevation. Titan has a 10,000-footer club, Iapetus looks to have a 60,000 footer club. One of the biggest questions, at least for astropointers, is which one of these is the actual high point. For the adventurous, determining which peak is the acme of this long, magnificent ridge could well be one of the greatest climbing and surveying expeditions in our solar system.
Said you will have several advantages when it comes to climbing on Iapetus. Perhaps the biggest one is the low gravity. A 200-pound individual will weigh about 4.5 pounds here, and that will make bounding up these heights at least a bit easier.
Another advantage of climbing on Iapetus is it'll be warmer, at least relatively speaking. Because of this moon's leisurely pace in orbiting Saturn, it gets the opportunity to soak up the sun. Its dark-colored terrain is great at absorbing solar radiation. Temperatures here can get as high as 226 degrees Fahrenheit below zero. This is a veritable tropical paradise for the Chronian system. So yes, it is still amazingly chilly, but not nearly as cold as the moons we've already checked out.
You'll also want to bone up on your navigation skills, because getting up to the top of this ridge will require negotiating around the numerous craters that have accumulated over the lifetime of it. And bring your ice axe and crampons, because this ascent is not for the faint-hearted.
The downside of the warmer temperatures is that you'll need to be prepared for avalanches as you ascend to the top. Iapetus is known for its giant, long run-out avalanches and landslides that can carry massive amounts of debris for many miles. Iapetus also has another interesting peculiarity due to its location. Way out here is a view you won't get from any of the other major Saturn moons. This moon provides you with a full view of Saturn in all its glory. You'll be far enough away and at a high enough inclination to see the planet, the entire expanse of the rings, and many of the moons we visited. It'll be a great culmination of your Saturn high-pointing adventure.
Once you reach the top, you will receive a spectacular view. If you look to the north and south, you will see the cratered terrain of this moon. And to the east and west, you'll be able to take in the splendor that is the equatorial ridge as it wraps itself around Iapetus. You'll be at an elevation of approximately 65,000 feet. It is the highest point in the Chronian system. It's also the third highest point in our solar system, and the highest point of any moon that we've yet discovered. As we depart from the ring beauty of Saturn, we can check off a few more boxes on our list. We have reached the top of 8 of the 10 highest peaks and visited 7 of the 10 largest moons in our solar system. Now we voyage out to the mysterious realms of the ice giants. I'm Skye Marthaler. Thanks for joining me on this episode of Rooftops of the Solar System. Before you go, click that red subscribe button below and leave a comment. Tell me what your favorite moon of Saturn was. I'll see you soon.